Let's solve problem 5.16 from Microelectronic Circuits 8th edition by Sedra and Smith. You have an NMOS transistor with a threshold voltage of 0.5 volts, operated in the triode region with a very small voltage from drain to source. With a voltage from gate to source at 0.7 volts, it is found to have a resistance of 1 kilo ohm. What value of VGS is required to obtain RDS equals to 200 ohms? So when we have a very small VDS in comparison to our overdrive voltage, we can leverage the following equation. RDS is equal to 1 divided by Kn, or mu n Cox, times W over L times V overdrive. And I can rewrite this as 1 divided by Kn times V overdrive. It can also be expressed as VGS minus VT. So I have a case where I have threshold voltage, gate to source voltage, and resistance. So I just need to solve for Kn first. So I have, once again, RDS equal to 1 divided by Kn times VGS minus VT, and I want to solve for Kn. So we're just going to flip Kn and RDS, right? So Kn is equal to 1 divided by RDS times VGS minus VT. I'll plug in some values. So we get 1 divided by 1 kilo ohm times VGS is 0.7 volts, and then VT is 0.5 volts. So I calculate Kn to be 5 milliamps per volt squared. Now we can solve for VGS in this new case. So this time we're solving for VGS. So let me write down the original equation again. VGS minus VT. Okay, we want to isolate VGS, so let's move VGS minus VT to the left side, and then divide RDS to the right side. So we get VGS minus VT is equal to 1 divided by Kn RDS, and then we just need to add VT to the other side. So we get VGS is equal to 1 divided by Kn RDS plus VT, which is equal to 1 divided by, so we have 5 milliamps per volt squared, times RDS, which is now 200 ohms, and threshold voltage doesn't change, it's just 0.5 volts, and I get 1.5 volts. So that's our answer to the first question. Second question is find the corresponding resistance values obtained when a device having twice the value of its width. So if you look at this first equation I wrote, how is the width proportional to resistance? Resistance is proportional to 1 divided by the width. So if I double the width, how does the resistance change? It's going to get halved. So R is halved. So that means in this first case, when we had a resistance of 1 kilo ohm, it gets halved to 0.5 kilo ohms. And then in case 2, when RDS is 200 ohms, it gets halved to 100 ohms. So that solves the problem. Thank you very much for watching my video. For any comments or video suggestions, feel free to contact me in the comments or by my email. Thank you and have a great day.